You know that feeling of being completely lost? Maybe it's in a new city, or maybe you're just staring at a puzzle totally stumped. Well, when you're navigating the unknown, you really only have two basic choices. Do you pick one path and just see where it goes? Or do you carefully check all your immediate options before you take even a single step? We're going to dive into this because it turns out computers face this exact problem all the time.
So, I want you to imagine you're standing at the entrance of a giant labyrinth. The exit is in there somewhere, but you have no map, no guide. At every single intersection, you've got a choice. Do you commit? Do you just pick one hallway and follow it as deep as you can go? Or do you play it safe, methodically checking every single connecting room before moving deeper in? This isn't just a riddle, you know. This is the very question that leads us to two of the most fundamental, most powerful algorithms in all of computer science.
So here's our plan. We're going to walk through this whole thing together. First, we'll officially enter the labyrinth and figure out what we're really talking about. Then we'll meet our two problem solvers, the one who goes deep and the one who goes wide. After that, we'll put them head to head. And finally, and this is the cool part, we'll show you how these maze-solving strategies are secretly running the apps you use every single day. All right, let's step into our labyrinth. But before we get hopelessly lost, we've got to put a name to what we're actually doing here. Because this isn't just about mazes. It's about a core concept in computer science called graph traversal. See, in the world of computer science, things like mazes or social networks or even the internet itself, we call them graphs. The rooms or intersections, those are vertices, and the hallways connecting them are edges. So graph traversal is really just a fancy way of saying, how do we visit every single room in a systematic way without getting turned around and going in circles? The whole point is to be thorough and, of course, efficient.
Okay, so let's meet our first strategy. And for this one, I want you to picture a bold, maybe even a little bit reckless adventurer. Their whole philosophy is super simple. Pick a path and just go for it.
This is depth first search, or DFS for short. And yeah, it does exactly what it sounds like. It dives deep. Our adventurer will charge down a single corridor, turning at every corner, going deeper and deeper and deeper until, bam, they hit a dead end. Only then, and only then, do they backtrack to the last place they had a choice and try a different path. It's all about commitment.
So how on earth does our adventurer remember where to backtrack to? They have a secret weapon. It's called a stack. The best way to think about a stack is like a stack of plates. You can only put a new plate on the top, and you can only take a plate off the top. It's a last-in, first-out system. So every time our adventurer sees a new path, they just drop a reminder on top of their stack. When they hit that dead end, they just grab the top plate, the most recent path they ignored, and try that one instead. It's a genius way to keep track.
So check this out. Here's how it plays out. When the adventurer enters a room, they add all the new doorways they see to the top of their stack. Now, because they always pull their next move from the top of the stack, they immediately go exploring through the doorway they just added. And that's the magic trick. That's what forces them to go deeper and deeper down one single path before they ever get to those older options waiting at the bottom of the stack. It's what creates that signature deep dive behavior.
Now, let's look at the complete opposite approach. I want you to forget the bold adventurer. Instead, picture a meticulous planner. This explorer is cautious, they're systematic, and they leave absolutely no stone unturned.
This strategy is called breadth first search, or BFS. And instead of diving headfirst down one path, our planner stands in the starting room and opens every single door right there. They take a quick peek inside each adjacent room before taking a single step further. They explore the maze level by level, like ripples expanding in a pond.
And this planner? Well, they've got a different secret weapon. It's not a stack, it's a queue. Just think of a line at the grocery store. The first person who gets in line is the first person to get checked out. It's a first in, first out system. Super orderly, super fair.
You can totally see how this creates that ripple effect, right? The planner adds any new rooms they find to the back of the line, but they always explore the room at the front of the line, the one that's been waiting the longest. This system guarantees that they visit all the rooms one step away before ever moving on to rooms that are 2 steps away, and so on. It's a beautifully simple system, and it means you're guaranteed to find the closest exit first.
Okay, so we've met our two heroes, the Go Deep adventurer and the Go Wide planner. Let's put them in the ring, side by side, and really see how their strategies stack up.
So on one hand, you've got DFS, the maze runner. It's a gambler, betting that the current path is the right one, but it's always ready to backtrack. On the other hand, you have BFS, which is like a ripple spreading in a pond, slowly, methodically, but surely covering every single possibility at its current distance before it dares to move further out. And it really all boils down to that one key difference you see here, the data structure. The adventurer uses a stack, and the planner uses a queue, and that one choice changes everything. If you just need to know if an exit even exists, the adventurer's deep dive might get you an answer really fast, but, and this is a big but, if you need to find the shortest path to the exit, the planner's level-by-level approach is the only one guaranteed to find. So mazes are cool and all, but why does this actually matter to you? Well, here's the crazy part. You are using both the adventurer and the planner every single day of your life, and you probably don't even realize it.
That go deep DFS strategy, that's what's homing under the hood when you're solving a Sudoku puzzle. You try a number and you follow the consequences. It's also used to find infinite loops in computer networks. Meanwhile, the go wide BFS strategy, oh man, that's everywhere. It's the absolute core of how Google Maps finds you the shortest route. It's how LinkedIn or Facebook can show you friends of friends by exploring your network one level at a time. It's even how web crawlers for search engines explore the internet.
And here is the real kicker, the punchline to this whole thing. Despite their completely different philosophies, our bold adventurer and our meticulous planner are often equally efficient. At the end of the day, they both have to check every room and walk down every hallway. So in computer science terms, we say their efficiency is O of V plus E. Basically, the time it takes is related to the number of vertices and edges. The choice between them isn't about raw speed, it's about what kind of answer you actually need. So the next time you're facing a really complex problem, think about our two heroes in the labyrinth. Are you just looking for any solution, fast, or do you need the absolute best solution, guaranteed? Because sometimes the most powerful way to navigate the unknown is to follow one of two very simple rules: go deep or go wide.